Okay, so today we're going to start trigonometry, the study of triangles. What I have here is already drawn is three triangles that are similar by AA, right? Angle, angle. The right angles and then the 70-degree angle. We know these angles up here are all 20 degrees, so we know they're all equal as well. So what I can do here is I can go ahead and write some proportions. So if I'm looking at this first triangle, I can say that the relationship of A over C is the same as E over D, right? Which is the same as I over G, okay? And if you look at all of these, A is opposite angle A, C is the hypotenuse, E is opposite E, D is the hypotenuse, I is opposite I, and G is the hypotenuse. For all of these are all opposite the 70-degree angle. I can write similar proportions with, say, B over C, F over D, and H over G, right? Again, for all of these, if I'm at 70, I'm the side next to it and the hypotenuse, the side next to it and the hypotenuse, the side next to it and the hypotenuse, right? All these numerators are the side next to the 70, and this is the hypotenuse. I could also write, let's see, I could also do A over B is equal to E over F, which is equal to I over H, right? Again, all these opposite the 70, next to the 70. Opposite, next to, or adjacent. Opposite, adjacent, etc. Right? I could write a lot of these different proportions. We're going to look at these three. So to recap, right, we have opposite, hypotenuse. We have adjacent, hypotenuse. And we have opposite over adjacent. Okay? These 20, 70, 90 triangles are all similar. So they're kind of a special right triangle in and of themselves, like we talked about before. They're just not as nice as they could be, right? But these relationships, right, this side opposite over the hypotenuse, in all of these triangles, no matter how small or big they are, no matter how they're rotated, this fraction will always equal the same thing. Similarly, the adjacent to the 70 and the hypotenuse in all of these triangles is the same thing. And opposite over adjacent, always the same thing in all of these triangles. Okay? I could say the same thing if I wanted to talk about the 20-degree angle, right? We know those are 20. I could say the opposite side over the hypotenuse is equal to the opposite over the hypotenuse, okay? And all of these same relationships would be true, okay? This. Okay, so here I have set up for us a little example. Okay, so this is a triangle, and I've made sure that the numbers all work with the Pythagorean theorem and everything. So what I know is that if I'm at 70, okay, then I know that the opposite to 70 is 14.62, and the hypotenuse is 15.45. Okay, so what I said was that was the opposite of 70 over the hypotenuse. Fair? So I can say this triangle is going to have the same relationship. I'm going to say, right, that this, the opposite is x, the hypotenuse is 10. Okay? I can use a calculator. I'm going to just, I can use a calculator to evaluate this. Doing so, I get 0.9462. I just divided in a calculator. Notice I'm rounding to 4 decimal places. Okay? So in this case, if I say this is equal to x over 10, I can solve for x, and I get 9.46. Okay? My side length, I'm going to round to 2 decimal places. Something we can worry about later. 9.46. Okay? I can do similar stuff, okay, with this triangle. So let's try this example. Let me try to erase real quickly. Okay, sorry. Okay, well, I can't erase. So anyway, I know that this relationship, opposite over hypotenuse, is equal to 0.9462. So that is equal to the opposite 12 over the hypotenuse. Okay, when I go ahead to solve this, I'm going to have x times 0.9462 is equal to 12, right? Make sure you understand what that means. And then to solve it, I'm going to do 12 divided by 0.9462, obviously my calculator, and I'm going to get 12.68. Okay, so that means this length here is 12.68. Okay? Okay, these relationships, so this is something you really want to write down. Write this down. If you need to hit pause, you can. Okay, so these relationships, opposite over hypotenuse, we've talked about adjacent over hypotenuse, opposite over adjacent. They're pretty important. That's why I picked them. And they have these names: sine, cosine, tangent. Okay, this, in parentheses, is what you see on your calculator. And in the next video, we're going to talk about how to use your calculator. Okay, if I said the sides of this triangle were 3, 4, 5, that's a Pythagorean triple, so we know it works. I could write that the sine of A, okay, so notice the abbreviation, the sine of A, so here's A, is 4, the opposite, over the hypotenuse, right? Okay, you try for the cosine of A. Can you write a fraction? Pause it, you try. Okay, so you should have gotten 3 over 5. And lastly, we'll do tangent of A. So pause and try tangent of A. Okay, if you do tangent of A, it's the opposite over the adjacent. Sound good? So we're going to do a lot of this. One thing I do want to point out, this is something you're going to have to memorize. There's lots of ways to memorize it. Well, there's a few ways. The most common way, and if you have a tutor or an older brother or sister, this is how they're going to tell you to remember it. So, toa. SOHCAHTOA. So if you notice, it's sine, opposite hypotenuse. Cosine, adjacent hypotenuse. Tangent, opposite adjacent. That is a great way of memorizing it. Okay, that's the most common way. Let's try another example. Okay, I'll use a different Pythagorean triple, 6, 8, 10. This time, can you find the cosine of B? What does the cosine of B equal? Pause, try. Okay, I changed up the angle on you. Here's B. Cosine, adjacent 8, hypotenuse 10. So the cosine is 8 over 10. You can reduce it if you want to, but you certainly don't need to. That's the cosine. Okay, let's try another one. Let's try the tangent of B. Okay, again, we'll make this 6, 8, 10. Okay, so the tangent of B, we look here, opposite, adjacent. So we're at B, opposite is 6, adjacent is 8. So it is 6 over 8. Okay, it's that simple. Talk about one last little thing. If I'm asked for, say, the sine of C, this we're not going to worry about. We are going to worry about it. You can't do it because if you're at C, the opposite and the hypotenuse, that doesn't make sense. We don't have an opposite side. So for now, we're not going to do we're not going to take a trig function. We're not going to do sine, cosine, and tangent of the 90-degree angle. So sine of 90, we're not going to do.